In this lesson, we're going to talk about how to graph an inequality on a number line, and we're also going to talk about one-step inequalities. So this is the basic groundwork for the inequalities unit. So if we look here, you probably recognize these four symbols here: greater than, less than, greater than or equal to, and less than or equal to. The main thing I wanted you to know from this slide is how we actually graph an inequality. So if you look at the greater than symbol, you can see that it has an arrow kind of going towards the right-hand direction. And you can see that our arrow on our number line is also moving in the right-hand direction. And the other thing I really wanted you to know here is if you look at the symbol, if you look at the greater than symbol and then the greater than or equal to symbol, you can see that the difference between the two is the little line underneath the greater than or equal to symbol. That's the equal to part. And what that means is when you just have greater than, you have an open circle, meaning that that point, -5, is not included in our inequality. Unlike down here, we have a closed-in dot. That means that 2 is included on our in our inequality. So the terminology that is used is inclusive. So that means that the one below here, 2, is inclusive in this inequality. Likewise with less than or equal to, it's the same thing. So if you look at the arrows for less than, you can see that it's facing the left direction. And the same thing with the less than or equal to, both going to the left. And you also have that open circle on the less than, and you have that closed circle on the less than or equal to. So basically what these inequalities are saying is, let's just look at the greater than one. It's saying that if I were to put a number there, like x is greater than, I'm going to use our example, -5, it means that all the numbers, all the answers to this inequality are numbers that are larger than -5. They can't be equal to -5. They have to be larger than -5. And that's how we represent it by that arrow on our number line. And that arrow is going into the positive infinity direction. And that is likewise with all four of these examples. Now, there's a very important rule in the inequalities unit, and you've probably heard it in the past. And the rule is when you solve an inequality and you multiply, when you're solving an inequality and you're multiplying or dividing by a negative number, it causes you to flip the sign over. Now, let me show you why that is. So if we look at this next example, you can see that 2 is greater than 1. I bet we can all agree that 2 is bigger than 1. But when you multiply or divide it by a -1 or just a negative number in general, we want to see what happens. So if you look at our balance beam right here, you can see that 2 is definitely, we can use the word heavier than 1. Now let's see what happens when, let's just go ahead and multiply it by -1 on both sides. And it's similar to an equation where whatever you do to one side, you also have to do to the other side. So when we do that, we get our answer, I'm going to bring it down here, of -2 is greater than -1. Well, we know on a number line that that's not true. -2 is not greater than -1. It's actually less than -1. So what happens here is it causes us to have to flip the sign. And now it's a true statement. -2 is less than -1. And you can see that by our balance beam here. Okay. Now let's go ahead and talk about these two notations that we've talked about in the past, but now let's go ahead and revisit them. This is called set builder notation. And basically what it is it's a shorthand used to write sets, often sets with an infinite number of elements. So given these two graphs of inequalities, I'm first going to go ahead and I'm going to write down what the inequality is that's represented on the number line. Here it looks like we have x is less than +4. And I knew that it's a less than because my arrow is going to the left. And I knew that it was also a less than because I had an open circle. And I'm always going to use that number that is represented on top of the circle, or below the circle in our case, and which is 4. So now that I have my inequality, I want to put this in set builder notation, or also known as set notation. I'm going to do squiggly brackets, x, such that x is less than 4, and then I'm going to end my squiggly brackets. And that's it. Here's another one. This inequality is x is greater than or equal to 5. My set builder notation, I'm just going to go ahead and add my x such that x is greater than or equal to 5, and my squiggly brackets. Okay, now we're going to be looking at interval notation, because throughout this entire unit, you're going to be asked to put things in set notation and interval notation. If you remember a little bit about interval notation, these are kind of the guidelines here in this box, and what it's used for is to describe an interval on a number line. So the biggest thing I want to kind of talk to you about is this note down here. We're going to talk about all of this rest right up here. We're going to talk about that in the examples. So, but the note here is that negative infinity, that is always going to be in the left-hand position. Always. It's never going to be in the right. What I mean by that is it's never going to look like this, where you have negative infinity on the right-hand side. It'll always be on the left. Same thing with the positive infinity. Positive infinity will always be on the right-hand side. For example, it'll never look like this with it on the left-hand side. So it's always going to be in those positions. And the other piece is it's always going to have parentheses. For example, let's say I'm going to put my negative infinity on the left-hand side. It'll never look like this, ever. Same thing. Positive infinity will never have a bracket. The reason behind that is infinity is not a finite number. Infinity is, we like to say that it is a theory or it's a direction. We're going in the positive or the negative infinity direction. It's not a number. The way I like to think about it sometimes is you can't put it on the back of your basketball jersey. You can't put infinity there because it's not a number. It's a direction. It's a theory. So let's go ahead and see if we can figure out what the interval is for this inequality below. Okay, so we can see that I'm just going to go ahead and write what the inequality is above it. So I have x is less than 4. Oh, this is the same one from above. Okay, x is less than 4. So you can see that my inequality is beginning, like if I read it like a book from left to right, I can see that it is moving in the negative infinity direction. So because I have that, I'm going to go ahead and start it off by parentheses, negative infinity. And I'm going to put a comma. Now, my inequality, the highest point on my inequality going from left to right is 4. So I'm going to write a 4 there. My 4 is not included in my inequality. And because it's not included, I'm going to use a parenthesis. If it was included, I would use a bracket. And that's what these are stating up here above. All right, let's try another one. I'm going to go ahead and write the inequality above here. X is greater than or equal to 5. All right. Now, reading it like a book left to right, I can see that the first number that I see is 5. That's going to start my inequality, and it's going to move into the positive infinity direction. So I'm going to write down my 5 first, and I see that the dot is filled in. So I'm going to write a bracket, comma, and my inequality is moving to the right, and it's moving in the positive infinity direction. Infinity always ends up with a parenthesis because it's not a finite number. And there's our interval notation. All right, we're going to be practicing these two skills throughout the entire lesson here today. So let's go ahead and move on to we're on the graphing inequalities. A little bit more with graphing. Okay, so our first inequality here, let's go ahead and figure out what the inequality is. It looks like it's going to be x is less than or equal to negative 2. Make sure you look at that sign, that symbol, and you look at that dot. Is it filled in? Is it open? Set notation is going to look like this. X such that x is less than or equal to negative 2. Excuse me. And my interval notation is going to look like this. I'm moving into the negative infinity direction, so I'm going to start with negative infinity with parentheses, comma, and then I'm going to go all the way up to negative 2. You can see that negative 2 is included, so I'm going to use a bracket to indicate that. Okay, one more. My inequality here is going to be x is less than 5. And my set notation, I'm just going to go ahead and add in my variable x such that, and then I'm going to write down my inequality. And my interval notation, again, I'm going into the negative infinity direction. So parentheses, negative infinity, comma. I'm going to go up to 5 this time, but this time 5 is not included. It's an open circle, so I'm going to use parentheses. Okay, now let's go from an inequality to a number line. all we've done so far is take it from a number line and create the inequality. So here I have x is greater than or equal to -5. Okay, so I'm going to look at that symbol first, and I see that I have a greater than or equal to. That means I'm going to have a closed dot, and that dot is going to be on the number that they give me. So -5, I'm going to go ahead and draw a little filled in dot, make sure it's fully filled in. And then I'm going to look at my symbol, and you can see that my symbol is facing to the right, so I'm going to take that all the way to the right. Perfect. Okay, now let's go ahead and put this in interval notation and set notation. We'll start with interval. All right, well, my lowest number reading left to right is going to be, oh, excuse me. Oh, computer's going crazy. There we go. Interval notation. All right. -5 with a bracket, comma, and I'm going up into the positive infinity direction with a parenthesis. My set notation, I'm going to do my little squiggly brackets, x such that x is, I'm just going to rewrite the inequality exactly the way that I see it. Perfect. Okay, now we get a situation here where we have x on the right-hand side. Before you begin graphing inequality, you have to have the variable on the left-hand side. So what I'm going to do is, I'm not going to use the word flip. I'm going to use the word turn. I have to turn this around so that x is on the left-hand side. Notice how my symbol did turn around as well. The open side of my symbol is facing the x in both situations. So my new inequality is x is greater than 4. That's the one that I'm going to graph. So let's go ahead and graph that. I have an open circle on 4, and I'm moving to the right. My interval notation is going to be parentheses 4, comma, infinity, parenthesis. And my set notation is going to be x such that x is greater than 4. I always want to use the one that has the variable on the left-hand side. All right, one-step inequalities. All right, here we go. Just like an equation, you're going to solve this, and there's only going to be one little glitch in it, and we'll show you that in example 2. All right, so here we go. The first thing I would do to solve an equation would be to add 5. So I'm going to do the same thing here with an inequality. I'm still going to show all of my steps. And you can see that I'm left with y. My 5s are going to cancel out. I'm going to bring down my symbol less than, and then I'm going to add -4 plus 5 is 1. This right here is my inequality. If I go put it on a graph, I'm going to go and put it on like this. I'm going to put a little 0 in the middle. I usually like to use 3 numbers, 0, and then the number that I have in my inequality and its additive inverse. And I'd like to use those numbers there. So y is less than 1. I'm going to have an open circle moving to the left. My interval, okay, so I'm going to have parentheses, -infinity, comma, going up to 1 with a parenthesis. My set notation, now be very careful here. Notice my variable is no longer x. I want to use the variable y. It's very important that you use the variable that's actually in the inequality. Y such that y is less than 1. Okay, look at example 2 now. We knew that when we were to solve a normal equation, we would solve this by dividing both sides by -4. And that's how we would do this for this problem as well. But there is a little glitch in this one. This is that rule. When we multiply or divide by a negative number, we have to flip the sign. So right now we divided by -4. That -4 causes us to flip that sign over. Personally, I recommend doing it immediately. The moment that you think about it in your mind, flip the sign, because it's easy to forget. M is less than -6. All right, so this is my inequality. Let's go ahead and graph it. All right, my interval is going to be -infinity up to -6, and it's not included. My set notation is going to be m such that m is less than -6. All right, my next problem here. All right, you can see that my x is on the right-hand side. So I'm actually going to change this problem just to make it more interesting. I'm actually going to put a negative down here. So go ahead and put a little negative there, and makes it a little bit more interesting. Okay, so what I want to do here, I want to, now, remember when we talked about the variable being on the left side? You can do that at the beginning or you can do it at the end, but do not do it in between, like in the middle of your problem. So I'm going to do it at the end because I want to make a certain point here. So I'm going to solve this by multiplying both sides by -6. There it is, -6. Now, notice how I multiply by -6. I have to take that sign and immediately flip it. My 6's are going to cancel out, and I'm left with 42 is greater than or equal to x. Now, notice my variable is on the right-hand side. I don't want it there, so I'm going to turn it around. See how I'm using the different terminology, flip and turn? So x is less than or equal to 42. Now, if you forget to flip the sign, or if you forget to turn it properly, your graph is going to be all mixed up, and then that causes your interval notation and set notation to be all mixed up as well. So be very careful with that flip and turn. So I have 0, I have -42 and 42, and I have x is less than or equal to 42. So I'm going to have a closed-in dot, and it's going to be moving to the left. My interval notation is going to be -∞, comma, 42 with a bracket, and my set notation is going to be squiggly bracket x such that x is less than or equal to 42. Okay, and I believe that is it for one-step inequalities.